So this lesson is about learning about chapter 2, 2.1, pure 2, chapter 2, about functions of graphs. Before we dive into the 2.1 chapter, let's have a brief overview of what this chapter covers. We're going to learn about the modulus function, learn about the range and domain, which some of you, if you've done further maths GCSE, you might have learned that. And then we do a bit of recap on composite function, inverse function, and then we're going to apply what we learned about range and domain functions into the composite inverse function. Then we look at the graphs of these two modulus function. We're going to learn how to combine all kinds of transformation, including the one in pure 1. You have learned about transformation, rotation, not rotation, reflection, and reflection. What else? Translation, and what else have you learned? And enlargement, stretch. So a stretch. Then we're going to learn how to solve some modulus equation problems. Right. So 2.1 about modulus function. So notes. So what is a modulus function, first of all? So modulus function, let me make it bigger so I get a bit more space to write on. Right. So notes. First of all, the modulus function, modulus function of a number, well, modulus of a number actually, of a number x is denoted as two straight lines, like a bracket, but in a straight line, like a bar, a prison bar, as 2 bars with an x is its non-negative numerical value. Small example, e.g., if we have a modulus of -5, it will turn into a +5. Or if you have just a modulus of +6, it will just make it positive. The modulus function y equals modulus of f of x. So it's the 2 bars and then the f of x. If f of x is less than 0, then y equals a negative f of x. If f of x is greater than 0, then y is just a positive of f of x. Modulus has a different nickname. Modulus is also known as, aka, the absolute value. Now, if you're using a normal calculator, the CG51, of course, what's it called? The most basic one, you know, the one using GCSE about the Casio FX something. You should see the top left corner or top right, depends on the mode of calculator. You'll see the button ABS. Okay, it means absolute. That's why. So if you press on that, you'll see 2 bars. That's the absolute. If you try to put -5 in there, press equal, you give you 5. Right? Let's look next. Example number 1, given that f of x equals 5x plus 3 minus 7 modulus, find the value of f of 2. So f of 2 means we sub in the 2 into it, part A. So f of 2 equals the modulus of 5 times 2 plus 3 minus 7. 5 times 2 is 10, 13. So modulus of 13 minus 7. The modulus of a positive number doesn't do anything, so it's just 13. 13 minus 7 is 6. F of -3 is modulus of 5 times -3 plus 3 minus 7, which is modulus of -15 plus 3 is -12 minus 7. Modulus of -12 is +12, so 12 minus 7 is 5. Okay. Oh, I made a mistake. No, I haven't. Okay. Right. So next one, you have a little bit of practice question. You can have a go at these questions. Let me rub off my writing. You can have a go at these questions. Whenever you're ready, you can press play. Just have a go at these ones. Okay. Whenever you're ready, you can press play. The answer, I'm going to write the answer. I'm not going through this. The answer is 5. The answer is 46. The answer is 40. This one is 16, 65, and 0. Okay. Any questions, do let me know as if you struggle with these. Right. Moving on. the graph. Sketching the graph of y equals modulus of ax plus b. So 2 steps. First step, you're going to sketch the graph of y equals ax plus b without the modulus. Next step, we're going to reflect the section below the x-axis in the x-axis. So let's say we have, okay, so this is the original. So this original. Okay, this original. So this is the original. This is the original y equals ax plus b. Then the reflected graph. So the mod of ax plus b will be, so any part below the x-axis, which is this part, will be now reflected in here. So it'll be like this. Okay. And then the part above x-axis will be the same. So red line is the graph of y equals mod of ax plus b. The blue line, blue graph original, is the y equals ax plus b with that modulus. Okay. Right. Next one. Example number 2, sketch a graph of y equals, I'll keep that in here, modulus of 3x minus 2. So we can do a draft using a pencil. So now using a pencil, let's draw the graph of y equals without the modulus. So when x is 0, y is minus 2. When y is 0, x is 2/3. So it'll be like this. That's the graph. Okay, so that's the graph of y equals 3x minus 2. So the real one, let me use different color, let me use green. The real one is going to look like this. 2/3. Anything below 2/3 will be reflected. And this y-intercept now becomes 2 because minus 2 flip, x-axis becomes 2. So that's the y, that's the x. This is the graph y equals mod of 3x minus 2. You don't have to show this working out to the examiner. It's this one that matters. All right. Next one. Practice, your turn. Have a go at the question. Whenever you're ready for the answer, you can press play. So let's draw the original one. The original one is look like this. So when x is 0, y is minus 7. And 7/4. So the answer would be like this. Okay, you should draw a separate graph, just a bit lazy. Okay, the green graph is the final answer. Okay, right. Example number 3. Next one, let's move on. So next page, example number 3, solve the equation that 3x minus 5 equals 2 minus a half x. Right, if we look at it graphically, okay, so I'm going to show you 2 ways, okay, graphically. So we're going to sketch, okay, so we're going to sketch y equals 3x minus 5. So we'll break the equation in 2 halves, and we're also going to sketch the 2 minus a half x in 1 together. So if I sketch both of them in, so let's do the first one, 3x minus 5. That's over 3, like this perhaps. So that's the y equals modulus 3x minus 5. Let me use different color for the second graph. Second graph, if we have y equals minus half x, when x is 0, y is 2. What's this one here? When x, that's 5 actually. This is 5. When y is 0, x equals 4. So it's going to be a graph like this, perhaps. Roughly. So that's 2, and that's 4. So when the equal graphically means where the 2 graphs intersect. So these 2 are the solutions. These are the solutions. These 2 are the solutions to the equation, solutions. Right, so how do we do it then? Well, to work out solutions of the graph, well, we can work out the simultaneous equation. So the simultaneous equation of this is, so let's call this solution 1 and solution 2. Right, solution 1. Okay, so solution 1. So solution 1 is a graph of, now can you see, solution 1 exists on the reflected part of the 3x minus 5 modulus. When 3x minus 5 is a reflected part, then that's the y equals negative bracket of 3x minus 5, because reflected, so it's negative in the front. And equation of y equals 2 minus a half x. So that's simultaneous equation. Solution 2 is, now solution 2 appears on the normal non-reflected part of the original graph, 3x minus 5. So y equals just 3x minus 5. And also on the graph of y equals 2 minus a half x. Now, if you solve the two simultaneous equation, whether using calculator or using manually, you can, I would suggest you pause the video, have a go and solving these two equations. You should get this one, x equals to 6 over 5, 1.2, and y equals to 7 over 5. This one, x equals to 2 and y equals to 1. Now, these two are not required, the y values, because all we need is x value. So that's one way, quite difficult. Algebraic way, the algebra way. Now, algebra way, we're going to consider two things, because inside the modulus, it could be positive, it could be negative. Consider 3x minus 5 is positive. I use plus VE means positive. Then, if it's positive, when you do a modulus of a positive, it does nothing. So 3x minus 5 equals 2 minus a half x. We're going to solve it in there, plus a half x, 3.5x, minus 2 to the right side becomes a 7, divided by 3.5, x equals 2. Find one answer. And this time, if we consider 3x minus 5 is negative. Now, if it's negative, what happened then? Now, think about this. If you have minus 5, turns to 5, it has the same effect of putting a negative in the front. So minus 5 becomes positive. So if 3x minus 5 is negative, we can put a negative in the front of a bracket. Negative 3x minus 5 equals 2 minus a half x. So when you want to solve the equation of modulus function, you consider two cases. The first case is where 3x minus 5 is positive, where you just do the whole thing without the modulus. The second part is you consider 3x minus 5 is negative, then the modulus symbols becomes a negative bracket. So negative, and then the modulus bar becomes a bracket. Expand a bracket, minus 3x, minus makes a plus 5, equals 2 minus a half x. Simplified equation, minus 3x to right hand side, add, that will become 2.5x. 2 bring it left hand side becomes divide minus 3. 3 divided by 2.5, I believe that's 1.2. You can see these are the answer matching up. So these two ways, algebra way is the way to go. Okay. Right. Next, practice question. Have a go at a question, see if you can try to do it. I think that was meant to be a 3 in here. And h of x equals 5. On the same axis, sketch a graph of y equals g of x and y equals h of x, hence solve the equations. So pause the video. When you're ready for the answer, you can press play. Right, here we go. So on the same axis, so let's draw in the axis, a pair of axes. Let me use black for the axes. Right, so your answer should be, so it's like this number when y is 0, that's 8/3. Am I right? 8/3, yes. And when x is 0, that will be 4. And h of x equals 5 is a line, horizontal line that goes through y is 5. So that's the answer. Part B, hands over the equation. So we know 2 cases. Okay, so case A, first case is when it's positive. So treat the bar as nothing, treat the modulus sign as nothing, and just solve it. And you will get -1 equals 3/2x. So x equals -2/3. The other case is or negative, put a negative in front. Square bracket -4 plus 3/2x equals 5. You solve that, you get x equals 6. This is your answer, which makes sense because if you look at the graph, x equals 6, that's x equals 6. And that is x equals -2/3. It does kind of make sense. All right, and that's the end. Oh, no, not quite yet. One more example. Next page. Sorry about the font size in here. Forgot to change it. Solve inequality. Same thing. Inequality, right answer in set notation. Same thing with inequality. You treat as 2 cases. The first one is where 5x minus 1 is greater than 3x. The other one is the bracket, 5x minus 1, negative bracket, greater than 3x. Expand bracket, so 2x greater than 1, x greater than a half. This one minus 5x plus 1 greater than 3x, greater 8x, divided by 8. So 1/8 greater than x. I don't like x being right hand side, being biased. X has to be on left hand side. It's like chips must be with ketchup and mayo. Well, if you disagree, you can't. So x has to be on left hand side. So x equals less than an eighth, or x has to be greater than a half. So in set notation, we'll go right. X colon, x has to be less than an eighth, or means the union symbol in set notation, bracket x greater than a half. And that's it. That's the answer. And that's it. That's it for the lesson.